Have you ever wondered how computers process and enhance images? Behind the scenes, it's all about breaking down visuals into numbers and applying mathematical techniques to create stunning effects or extract useful information. Today, we'll explore how grayscale images, kernels, and filters work together to transfer raw images into meaningful visual representations. A grayscale image is made up of an array of pixels values ranging from 0, which is black, to 255, which is white. Think of this array as a grid, where each value represents the brightness of a specific pixel. Now, when dealing with color image, things get more complex. Instead of one array, there are three separate arrays called channels that store pixel values for red, green, and blue hues. Together, these channels combine to create a color for images we see. So how does filter works? Most images process involves applying filters, and these are driven by a key component called kernel. A kernel is essentially a small grid of weight values. Think of it as a stencil for transforming images. The process of applying the kernel is called convolution. And here's how it works. The kernel is passed over the image in a step-by-step fashion, horizontally or vertically. At each step, a weighted sum is calculated using the original pixel values and the kernel weights. And lastly, this process generates a new array that represent the filter images. The result is the filter image typically has a visual effect based on a specific kernel used. For example, of a filter that is the Laplace filter, which is specifically designed to highlight the edges of shapes in an image. When the Laplace filter is applied, it identifies the area of rapid intensity change, like where one object ends and others begin. The result is an edge enhanced image that emphasizes the contour and boundaries of shapes. By combining filters and convolutions, image processing unlock countless possibilities of enhancing and analyzing images.